So earlier on this chapter, right, actually I mentioned to you why do we need to have log function, right? One of the reason is because actually this log and log function, they actually able to change a curve into a straight line equation. When you are having a straight line equation, then it's easier for you to estimate some values that you need to find out, like gradient, y-intercept, and so on. Alright, but if you're having a curve, actually you cannot estimate what are the gradient or what are some certain values that you need to find out. Okay, so here we come to the part already, which is power law. So that means when you have a curve, actually by taking log or long at both sides, you can change your equation to a linear form. All right, so this is what you can see from the learning outcome here. So use logarithm to logarithm function to transform a given relationship to a linear form, and hence determine unknown constants by considering the gradient and also the intercept. So that means after this video, you should be able to convert a certain curve into a linear form. And after that, by using the gradient and also the intercept from the linear form, you can estimate some unknown or values that you want to get. Right? Okay, so we call it as power law. Okay, so they are actually in our syllabus to convert a curve into the linear form. There are two patterns only. The first one is y equals to ax power n. The other one is ab power x. There are two patterns like this only. We are going to change these two curves into a linear form. Alright. Okay, so generally, if you want to change y equals to ax power n into linear form, what you need to do is you need to take log or log at both sides. So when you take log or log at both sides, then you are having this. And after that, you expand everything. You'll get this equation. Alright, so when you have this equation, generally you can compare it with a linear equation. So what is the pattern for a linear equation? It is y equals to mx plus c, right? So y equals to, I will make this as a c plus mx. Okay, so that means what? If you compare, you can see it like this. Okay, y is log y. Okay, x is log x. So your c will be log a, and gradient m is n. Okay, so what's the meaning for y and x here? So the y here means the y-axis. That means if y-axis is log y, and then if your x-axis is log x, so when you sketch a graph for y-axis and x-axis with log y and log x, generally you will get a straight line. Okay, so after you get a straight line equation, a straight line, you can actually estimate the value of a and also the value of n by looking at the intercept value and also the gradient. So you have to compare. Right, so y equals to mx plus c. So this is what you did, how you compare. Okay, so if let's say you don't want to take log, you can also take log. That's why I show you here in our notes. Okay, so the gradient of the straight line, that means the m, is actually the n, the value of n. And the intercept is actually log a or log a. It depends on what are you taking. You are taking log or you are taking log. If let's say you are taking log, then the c intercepts log a. Okay, so this is the first pattern. Right, then how about for the second pattern of the equation? So if let's say for the second pattern of the equation, the process is still the same. Okay, so you can start to write out first. This is the original equation. Okay, maybe you don't know the value of y, you have some value of y and x, but you want to estimate the a and b, the value for a and b. Okay, so to estimate it, you need to change it become linear equation, linear form. So you take log both sides again. And then when you expand it, it will become something like this. Expand everything, all right? Okay, then again, if you try to compare the equation here, y equals to mx plus c. Okay, so again, your y-axis should be log y. And then the x-axis should be the x. x is not ln b, it should be the x. Usually we will link y with y exists, the value with x exists. Okay, so if you compare it against c, the intercept will be still ln a, and then the gradient is ln b. So if let's say you know the gradient and intercept, right, the value from the graph, then you can use it to estimate the value of a, and also you use the m to estimate the value of b. Okay, all right. So again, as what I said, the y here means the y in exists, and then the x here means the x exists. Okay, so if you want to convert the curve into a straight line or linear form, then generally for the first pattern like this, when you want to convert it into a linear form, your y-axis must be ln y, your x-axis must be ln x. Then after you sketch it, you will see that you roughly will get a linear form equation or linear form graph. And then if let's say you're having this second pattern here, when you want to sketch the graph and change it to become linear form, then your y-axis should be ln y and your x-axis should be x. So the idea is something like this. Okay, so how are you going to convert it and so on? I will show you later. There are some examples to show you later. Okay, you'll learn from that. Alright, so let's have a look at example 9 first. Let's talk about some very basic question. Okay, so for example 9, if let's say you're having this equation log y equals to this value, where log y is log base 10y, they want you to express y in terms of t by equating the right hand side to log a plus t log b. Okay, so this is your original equation. Okay, all right, and then they actually want you to equate the right hand side to log a plus t log b. So this is how your log y is also equals to log a plus t log b. Okay, so why they want you to compare it like this is because they actually want you to compare it with the linear equation, linear form equation. All right. Okay, so again, by looking at this one, you compare log y is log y, nothing special. Okay, so log a you compare it with 0.322, t you compare it with t, and the log b you compare it with negative 0.531. Okay, so when you direct compare the value like this, right, you can get the value of a. So log a equals to 0.322. Therefore, the a will be 10 power 0.322. So here you need this very basic knowledge on the log exponential function, how to change log become exponential, how to change exponential become log, all this. Okay, so the value of a that you get should be 2.10. Okay, so you get a value of a already. Then now you want to compare log b with negative 0.531. So log b equals to negative 0.531. So how can you get a b? It will be 10 power negative 0.531. And then from there, you should be able to get the value 0.294. That means what? That means the original, after converting into a linear form, this is a linear form equation, this one. Okay, and now they want you to write it back into the original equation. So to write it back to the original equation, you need to have a and b first. Then after that, only you start to find out the original equation. So log y equals to log a plus t log b. Okay, so now you want to express this equation to y in terms of t. That means you don't want to have any log. So if you don't want to have any log, I think I told you last time, right? If you want to cancel off the log, you have to group everything, left hand side and right hand side, with only one log each on each side. And after that, you apply the property of the logarithmic law to combine them. Okay, so when you combine them, left hand side got only one log, right hand side got only one log, then you can straight away cancel it. And what do you have here? You will have y equals to 2.10, 0.294, power t. So this is actually the original equation. And when you change it become linear form, it's something like this. So we are doing it the other way around. That means they give you the linear form, and by using the linear form, they want you to find out the original equation. Okay, so this is what we have for our example 9a. Alright, so if you roughly know what am I doing here, then you can try part B yourself. You can pause the video here and then you try the part B yourself first before you check for the final answer. Okay, right, so let's continue with the part B. Okay, so for part B, original equation is log y equals to 0.7 plus 2 log x. Okay, so they want you to equate the right hand side equals to log a plus b log x. Okay, then again, you can do the direct comparison. So log y is log y, log a is 0.7, b is 2, log x is log x. So from here, I think it's quite straightforward because you can see that log a equals to 0.7. If you want to know the value of a, it will be 10 power 0.7, and therefore you'll get a value of a, which is 5.01. And then for b, the value of b is very straightforward. You just direct compare it, no need to do any other thing. So b equals to 2. Okay, so once you get a and b already, then now they want you to express y in terms of x. So y in terms of x, you will have log y equals to log a. A is 5.01 plus 2 log x. So to combine them, you need to apply the log properties. Okay, so the number in front, you move it back first, it will become x squared, and then you multiply it together because of the plus. So you can have left hand side 1 log, right hand side also 1 log. You can cancel off both of them, and you are having y equals to 5.01 x squared. So this is the original equation. Alright, so I hope that you can see how we actually rephrase it and compare the equation. Then how are we going to change it to become curve? So example 9 is they give you the linear form equation, and from the linear form equation you use them to find back the original curve equation. Okay, so this is what you have for example 9. Alright, okay, so for the next video we are going to discuss example 10. So for example 10 is they give you some data, and from the data and also from the data they actually want you to find out the original curve equation. Understand? So that means you still need to use the data to sketch graph. After you sketch a graph, then only you use it to find back the original equation. So for example 10 and 11, it involves graph. Right? Okay, so we'll discuss this in the next video. So for this video, hopefully you roughly have the idea how we compare the equation, okay, with the y equals mx plus c, and from there, how you actually get the unknown value that you want to find out. Alright, so we'll discuss the graph part next video.